We have parents and students visiting our engineering program at Northport High School. And our engineering programs are 3 and 4 courses for students to take during their career in high school. And it helps prepare them not only to understand the field of engineering in many areas, but also to apply math and science skills while learning computer-aided drawing and design, 3D modeling, robotics, programming, designing real-life problems and solving real-life problems.
Before you even make anything, you have to learn the dimensions of it, and it's pretty easy. As like you're gonna get tutorials that show you everything. It's not that hard at all. It takes some time though. It takes a lot of time.
They actually get to do hands-on in this class. They get to use the tools and the products that are used in the industry. Our students over the 3 years in the program get to work towards an industry certification. And they're actually working with local industries, helping them solve their problems today, doing designs for these companies.
Helps me learn about new things, and it kind of is fun to work with the 3D models and working on SolidWorks. And then I get to have some experience for actually doing this in the real world, and I get to help out a lot of the local business to help Florida and Northport grow and prosper.
I've been in this class for 3 years, and so far we've worked on the trebuchet and SolidWorks and the robotics also. So the first year we worked mostly on SolidWorks, and then we go to robotics, and then we go to trebuchet, and then we come back to this basically. And right now we're working on a pirate ship where we all make pieces and then we're going to assemble it together.
One of my favorites is we have a program called SolidWorks where you basically get to make 3D designs of basically anything you want as long as you know how to use it. And the best ones that they picked, because we don't have a whole lot of material, got to be printed, and you can actually see some over there.
Well, right now our 3D printer is making another student's anchor. Well, right now the laser is putting on layers. For this one it took about an hour and 20 minutes. And then after it's done, there's a white layer. The shiny white layer on the bottom goes through a chemical bath and it will dissolve.
I like the creativity of it, the fact that it's not really just all lecture-based or all just sitting in front of your computers and he gives you a presentation. We do that from time to time, but very rarely. Yet you actually get some hands-on experience with it, and you really get to become an engineer, not just learning what it's like to be an engineer.
In a program that may be a STEM type of program, the science, technology, engineering, math program, if you can infuse this creative piece to it or the creative flair for it, then competitively it's going to put you in a better place. Now in Sarasota County we have the arts, and so if a student can bring that creativity to the table along with that rigorous coursework, that's what they're looking for in the workplace now.
Last year, over the summer, I got an internship with Milliken Awnings, and I get to design and make these awnings for them so that they can make these adjust to their specifications that they need and make it easier for their whole company.
Engineering is a combination of math, science, technology, but you don't have to be the best student at every one of them. You need to be able to think, try. It's okay to fail. It's one of the big lessons we learn up front in being an engineer. You need to be able to try things and fail. That's okay. That's how we learn.
Oh, to see light bulbs go on in the kids' eyes, the aha moments, especially when you first break out the technology and you see their eyes open up and they want to get their hands on it and see what it can do. After a while that wears off because they realize they actually have to learn and it's not just fun and games.
Well, I did my science fair experiment with TI Inspire and the dissolved oxygen probe, and it basically tells me how many dissolved oxygen in different types of water. Well, without the technology that we have, we wouldn't have been able to run experiments such as this, or another experiment was to find out how much fermentation is in yeast, and we wouldn't have been able to do that either. The program is an all-around great program. Like, there's so much things to do. Like, we also have the robotics in it and stuff.
Like for this one, we have what is this?
It's the toss-up, right?
I think it's the VEX toss-up, and we have to build our robot and program it to do some kind of autonomous mode, and then we have to program it to compete in this against 2 other people on a team.
And right now we are working on robots and programming them to complete an obstacle course. You have to be imaginative and creative, and then you have to be able to program it so it can make the turns and pick up the objects. There's instructions online on how to make the basic ones, but for competitions, you pretty much have to make it from your own imagination. It's very fun, and we're lucky that we have it, because a lot of schools don't.
You know, it's no longer a job that's directed by a supervisor, somebody, you know, in a linear pathway. It's now collaborative work. It's collaborative designs, and it's the ability to communicate, its ability to work at a high level, and its ability to communicate with peers and work with them. So that's what we're trying to do here, and I think Northport is doing a great job of it.
This is the TEL Lab, where you can come to collaborate on projects that would require teamwork, such as in engineering, like how we built the ballista. We could come here and, as a group, work on the active boards or on the tables, which you can write on, sketch out plans, and see how we would do things.
Well, I didn't expect to like it this much, but before I was sort of bored of it and I thought it was going to be a waste of time, but now that I'm actually in there, I love it. I mean, every day I'm on SolidWorks most of the time, and let's say during class, during school, if I'm not doing anything in my other classes, I would ask to come over here and work on it. It's pretty good. Well, I'm going to go into computer engineering, but I want this to have something to do with my future. Like working with this and SolidWorks, it's just amazing. I want that.
I'll see you there.
The engineering program is one program that can introduce students to how they can apply academic skills in real-life problem solving. And the New York Times on Sunday had a wonderful article showing how math and science brought into an application such as an engineering program for career and technical education help students understand that they are good at this, and it is a lot of critical thinking and application of those skills.
A lot of it is just life skills that you become familiar with, like even if it's so much as cutting a board or nailing something in, it's just you learn how to do it and you get to practice it, and even if you don't plan on becoming an engineer, there's still a lot you can learn from this class.
And try to teach them about robotics and programming. Well, when I finish a project, I'm happy because I finished a project and I actually did something that is useful. And I'm applying what I learned in school, so that makes me a lot more happy about working in school and in class.
The work he's doing will change that company and the way they do business. You know, they can expand into new markets, do new things that they never thought possible without this capability. And it's one of my students that's helping make that happen.
This is some things that you'll be doing in the engineering work field. We practice how to work in teams, how to split things up, how to really just get things done, whatever they may be, and meet a certain deadline. And we fairly met ours, and it shows you we get some practice before we get out there as engineers, if most of the people are planning on becoming engineers.
And I think an engineer is born. There's something inside an engineer that just has that curiosity of how something works and how can I make it better. They don't take no for an answer. They like the challenge. I think that's what motivates them and drives them, is that challenge. That's what makes a good engineering student. And someone that's not afraid to fail the first time. Very few engineering projects succeed the first try. So don't get discouraged, don't give up. Have that drive and keep at it, and you'll succeed.